is for Year 12 Further Maths. We're going to look at exercise 11F. Okay, we're going to break it into three parts. So first part is talking about binary and permutation matrices, and the second part would be talking about communication matrices, and the third part will be talking about dominance matrices. Okay, so the first part, we need to know what a binary matrix is. Okay, so a binary matrix is a matrix with only zeros and ones. So as you can see here in this matrix, I only have zeros and ones. Zeros and ones on the second matrix as well. So only zeros and ones are known as binary matrices. Permutation matrices are matrices which is only one on each row and column. Okay, so if we can look at this matrix here, we can see in each column we've got at least, well, we have exactly one in each column. Okay, the rest being zeros. And if we look at it in a row view, so I'll just do this in another color. If I look at it in a row view, then I can see there's only one as well. Okay, so one on each column, one on each row. Okay, and I've given an example of a 5x5 permutation matrix. Okay, so we can see that I have one on each row and one on each column. Okay, so it satisfies the definition of what a permutation matrix is. This happens to be the identity matrix for a 5x5. And identity matrix by definition are considered to be permutation matrices. Okay, so the next thing I want to cover is what a permutation is. A permutation are different arrangements of the same elements. Okay, so if I have the name Sarah, a permutation of the name Sarah is, Sarah written backwards, or any other jump, and any other mix-up of these letters. Okay, so if we want to apply permutation matrices, and I wanted you to read example 23 of page 399 from the text. If we times something by a permutation matrix, let's just say matrix X. Okay, X happens to be a column matrix of three letters, TAR, so tar. If we times X with Q, okay, Q with X, sorry, we want to pre-multiply. Pre-multiply means we're doing it before, so we're timesing Q before we, Q becomes before X, so we go Q times X. So if I want to times Q by X, so 0, 1, 0, 1, 0, 0, 0, 0, 1, and I'm timesing by X, TAR. Okay, we're just treating this as as numbers. This is a 3 by 3. This is a 3 by 1. Okay, so these numbers agree, so they can be multiplied, and the outer numbers give me what my resulting matrix will be. It will be a 3 by 1, so it will be a column matrix with 3 elements in it. Okay, so remember the rules of matrix multiplication. I need to times, if I can just select that, I need to times the rows with the column. Okay, we only have one column. Okay, so we have 3 rows, we times that each by the column. Okay, so first row, 0 times t, you times the elements together and you add them. Okay, 0 times t, 0. 1 times a is a single a, 0 times r is 0. So 0 plus a plus r, plus 0 plus a plus 0. So we've got an a left over. Okay. Second column, second row times the first column. So 1 times t. We know there's 2 zeros here, so we don't need to bother multiplying because we know that 0 times these 2 will give you 0. 0, 0, 1, so 1 times r is r. Okay, so as we can see, when I multiply this by the permutation matrix Q, I can see that the letters rearrange themselves. Okay, so what the effect of a permutation matrix generally, unless it's identity matrix, Okay, that's sort of a special case. When you multiply anything by identity matrix, whether it's pre-multiplying or post-multiplying, you always get the same thing back. It's like multiplying by 1 in the number world, in, your normal number world. If you multiply anything by 1, you get the same thing back, okay? However, if it's not a permutation matrix, and it's not identity matrix, and it's a permutation matrix, then we know that you get something different. It'll change the order of your original matrix. So if we pre-multiply by q squared, what would happen? Okay. Well, the interesting thing is, if you multiply a permutation matrix by itself, okay, so let's do it on a calculator. I don't want to do a 3 by 3 by hand. Okay, so if I multiply q, I'm going to enter this on my calculator. 1 0 0 0 0 1 1. If I try to multiply by itself, I can just square it. Okay, so q times q is just q squared. I get q squared equals 1 0 0 0 1 0 0 0 1, and that happens to be an identity. Okay, so if I multiply a permutation squared by x, I would always just get x, because this is the identity. Okay, so it's like multiplying by 1 in the matrix world. If you multiply something by 1, you get the same something back. So we'll know that it will remain unchanged. It will still be TAR. Okay. So that's something that that's a fact that you need to remember. Okay. Okay, so is always equal to the identity matrix. Okay, and you have this in your sheet. What if you post multiply q or q squared? If you get multiplied by q squared, you get the same thing. Same thing back. If you post multiply by q, let's see what happens. Okay, so if we post multiply by q, let's see what happens. Let's see if we can actually multiply it, because we've got a 3 by 1 matrix. TAR is a 3 by 1 matrix, and that's a 3 by 3. That can't cross multiply. So we need to actually physically change Q, well, TAR to a row matrix, because you can't, they're incompatible if I do it that way. 1 0 0 0 0 1. So this is now a 1 by 3, and this is a 3 by 3. You can see these agree, so you get a 1 by 3 at the end. So let's see what happens. If I multiply the row with the column, okay, and the 3 columns there, what do I get? So I get an A, I get a T, and I get a R. Okay, ATR. So you can multiply by Q, but you need to change the original matrices which you want to multiply, which you want to have multiplied, or which you want to have permutated. Okay. So what happens if matrix X is a row matrix and not a column matrix? Can we use a permutation? Yes, you can. Yes, you can, and I've just shown you. You need to change. You need to first change the permutation matrix so that it is a row matrix. Okay, they need to be compatible. Remember, matrix laws apply. Okay, you can't just multiply it straight away. Okay, so what happens if you? Can we use permutation? Yeah, we can. So we just needed to make sure we know whether we're post-multiplying or pre-multiplying. Okay, remember this permutation matrix actually jumbles the order of the letters. However, depending on whether your original matrix, the one you want to jumble, is a column or row matrix, it determines whether you actually post multiply and pre multiply. Okay, I'll stop there and we'll go on to communication.